we will hear from Mike Kudehi, who will discuss premise plumbing design and why it matters for building water use, energy use, and human health and safety. Vice Chair of the Water Tag and a member of multiple green building committees, including ASHRAE 189, ASHRAE 514, the Green Building Initiative's Water Subcommittee, as well as Chair of the National Green Building Standards Water Subcommittee. For 15 years in the building code development space as the Codes and Training Specialist for the Plastic Piping and Fittings Association. Mike is also the Regulation and Sustainability Specialist for the association, so he heads up their industry, LCA, and EPD work.
So it's great to see so many designers and engineers in this session. I'm going to try to go pretty quickly with my material, so there's plenty of time, but you can always contact me and ask me questions afterwards. So I want to quickly cover some current water quality concerns, how you can design around those concerns. I'll talk a little bit about energy and also a new novel technology, and that's the smart leak detectors. So first up is the current water safety and, of course, concerns we all have because of COVID. And the issue is really an accelerated issue that we had before the pandemic, and that was opportunistic premise plumbing pathogens. I didn't make that up, someone else did it, but it's a pretty good alliteration. It involves water age, temperature issues, design, and operations. A little bit of history. Your plumbing systems in your buildings, the piping, sizing, is designed due to the codes. And where did the codes get their designs? Well, they got their designs from someone named Roy Hunter, who in the 1940s did some statistical analysis to make a determination of just how big these pipes should be to work perfectly 99% of the time based on statistical use of the fixtures within that building. The 1940s were an interesting age for buildings. It was, here's the Commonwealth building in Portland. It was one of the first of the modern type constructions of buildings. So the 1940s were certainly an interesting period. And this is where a lot of our buildings that we're so used to today actually initiated. Also, by the 1940s, the use of disinfectants like chlorine and increasing attention to how buildings were being plumbed prevented diseases that were once quite commonplace. Deaths from things like typhoid fever and other waterborne diseases really plummeted by the time you were into the 1940s. So we had a really confident period of time there as far as water quality goes within buildings. And you can't leave the plumbers out of that. The plumbers, they consider themselves people who protect the health of the nation. And that's true, because if you can prevent waterborne diseases, you stop a lot of harm. Of course, nothing was perfect yet. One of the tools at the feet of the plumber there is that small bar of lead. So we have made improvements since then. Starting in the 1990s, we really started reducing fixture flow. And we're getting to the point where I think we're at the practical limit of reductions here. But certainly, if you look at the data, you can see we've really reduced the water consumption rate at fixtures, even in an ordinary home, versus what you would have had in the 1940s, certainly. Then we came along, right? And we asked for even further reductions in the water consumption of buildings. And one of the things LEED does is ask you for a 20% reduction. And now we have the pandemic. And what has the pandemic done? Well, the pandemic has emptied especially our commercial spaces and public spaces, to the point where some of these buildings are completely shut down for extended periods of time, and others are operating at an extremely reduced occupancy rate, and possibly for a long time to come. We may see a lot of other issues like urban flight. So what all these things have done is increase the water age within your building's plumbing. So the summary again is, the plumbing is really engineered for buildings and fixtures of the 1940s. Since then, buildings have become larger, far more fixtures have been installed for occupants. It's not uncommon now for buildings to have more restrooms than anything else. Fixture and appliance consumptions have also been reduced greatly. We've also reduced the temperature of hot water storage in buildings, and we did that several decades ago, I believe, to reduce scalding risk. But in plumbing, there's always unintended consequences to things, and you have to be really careful with what you do and what you change, because when you change the code, you're changing things at a national level. And if you do something and get an unintended consequence, the whole nation will suffer for it. So you do need to be careful. Green building has asked us to conserve even more water than we had previously. And again, then we got stuck with the pandemic, which shut down buildings, lowered occupancy rates, and encouraged some urban flight. So in the control of things like pathogens within plumbing building systems, there's really a few approaches, but the main ones are disinfectants and temperature control. So if you're using chlorine, for example, it doesn't stick around forever. It decays over time because it is always oxidizing materials within your plumbing system. You probably have a few days to deal with. And once you get under that 2 milligrams per liter level, it starts to lose the ability to control pathogens. So you can't just leave your water sitting around forever. The other thing that controls pathogen growth and replication in your plumbing system is the temperature ranges. So in this case, particularly for Legionella, there's a dormant range. If your water is cold, it does not grow, it doesn't expand. So if you can keep your cold water cold, you're in good shape. But there's a growth range, and it's typically warm water. Now you start getting into your 120s and 140s, you start killing off pathogens. So that's the range you want to be at. Unfortunately, when we lowered our temperature storage, we had some negative impacts from that because some folks were storing their water at a temperature range that was allowing for pathogen growth. So what can I do? You want to engineer in the good stuff in your buildings. You want to right size everything in your plumbing. You still have to follow the codes, and we are looking at ways that we will change sizing in the future, but that will take a lot of effort and research to make sure we don't have any unintended consequences. Smaller pipe might not be the answer. We've got to figure that out. So things you can do is have a low system volume. In other words, don't have a lot of dead volume between the source of the water and the fixture. Avoid at all costs dead legs, and that's a pipe that doesn't go anywhere because the water age in that pipe is basically infinite. Try to target fast or hot water delivery to your taps. Cluster fixtures where you can. Don't have anything way off on one side of the building that's only going to be used intermittently. Try to get higher water velocity. You do that with smaller pipe. That may help clean some of the biofilm deposits that we find in piping systems that can sometimes hide some of these pathogens, especially Legionella. It's possible that you may want to have more residual disinfectant, and this is tricky because you may have to become a water purveyor yourself. So that's a very difficult pathway to take. Point of use filters are always a possibility. And again, the goal here is to do no harm to the incoming water quality. There are tables in the plumbing codes to help you design for minimum volumes. This one's from the IPC in the appendix. USGBC has also responded to this issue in the pandemic. And it's not just water, obviously. There's air quality concerns and other concerns too. So if you're going to screenshot anything in my presentation, maybe this is the page you get because there's an awful lot of words here. And you can look up all of these different documents or perhaps visit the USGBC's website to find out what their guidance and recommendation is if you have to operate a building that's been shut down for an extended period of time due to the pandemic, deal with the water quality, deal with the air quality, and everything else. So here's a little tidbit on energy. So on the side of the picture, that is a tankless water heater. It's an electric type, so they tend to be small. This one puts out about 1 to 2 gallons a minute. And you can see that the energy demand of this device is 11 kilowatts. That's how much power it needs anytime it is running. So you can consider a hot water fixture to be an energy device. Isn't that an interesting way to look at it? And if this 1 to 2 gallon per minute device runs at 11 kilowatts, and so does the fixture, well, then the fixture is an 11 kilowatt device. What's 11 kilowatts? Well, it's 180 60-watt light bulbs. That's a pretty surprising number to most people. So here's an interesting way to look at what this fixture represents. If you turn on your hot water fixture, and maybe you have some cold incoming water, and you need 11 kilowatts to heat it up to 1 to 2 GPM, this is how many light bulbs would be simultaneously lit by that amount of power. But wait, we're supposed to switch every one of these incandescent light bulbs out in our building for one of these LED buildings, one of these LED lights. And what would that mean? Well, this is about 9 times more bulbs. So one hot water fixture running normally is about 1,600 6.5 watt LED bulbs. And that's just for 1 to 2 gallon a minute of instant hot water. I guess the lesson here is, technologically wise, we were able to improve lighting probably by a factor of 10 or more. But the physics of water are such that you will never need less energy to heat water. All right, my next topic is the Smart Leak Detection Devices credit. So what are these new leak detection devices? These are inline internet-connected devices that contain a number of features. One of them is a microphone type of a transducer that listens to the pressure waves in the water. These typically will also contain a shutoff valve. They will be connected to Wi-Fi and sometimes to the cloud. There's a number of manufacturers with different thumbprints, but this is generally how they work. And they're amazingly accurate because sound just travels better in water than air. That's some of your physics for today. And when these devices determine that there's an upset condition because they're listening to the sound of the water system, they notify you on your smartphone. They let you know that you've put 100 gallons in a 90-gallon tub, or that some other factor is going on that requires your attention, and you can even shut off the flow remotely. The current limitation on these is about a 2-inch size for commercial buildings, and there are multiple manufacturers producing these. They've done a study where places that have installed these devices, 300 homes in this particular case, and about 10% of them had some significant leaks that the devices discovered. So they certainly have some payback. So when these devices are listening to the water events, what they can do is they can detect the sound of water freezing into small ice crystals. This means you may be able to respond before you get a frozen pipe burst. They can hear the sound of pinhole leaks. These are the very small leaks that do a lot of damage within walls. Doesn't save a lot of water, but it can save your building from a lot of water intrusion, mold, and air quality issues. And over time, they learn your system. And again, they can do things like tell you you've probably overfilled your tub, you've left something running that shouldn't have been left running. And because these systems are internet enabled, I think their future potential is probably more enormous than we can even think. I would imagine them being able to learn things like the sound a valve makes before it fails. Wouldn't that be interesting to be that guy? If adoption of these things is high, there could be a lot of useful regional and neighborhood data generated too. I'm not sure what they could be, but you can think of things like herd pressure drops and problems, or other issues along those lines. And certainly, our tag is working right now to include language to put these devices in. And I think that's all I have for you today. Thank you.